We are Team 24 of Section 15 of Professor Lyon's class. My name is Katie DeGuider.
I'm Maddie Hollett.
I'm Jeffrey Chang.
I'm Luke Gillis.
And this is our design project.
Our team has been hired by Kimberly Clark to create a method for separating hand towel waste from other waste within the restroom with a contamination level of below 1%. This issue does not only affect Kimberly Clark, but it also affects the users of paper towels and the environment surrounding everyone. The need for this solution is critical because it will allow for the towels to be composted and reused for another product or in another way instead of heading to a landfill. This solution needs to be safe and accessible for all users, while also minimizing the cost and the change in users' behavior patterns in order to use the solution.
Our first prototype is the rotating trash chute, and the second prototype is a combination of a connected sink, paper towel dispenser, and trash can. Our first and second prototypes did not meet the criteria and constraints, and also did not score as high as our third prototype on the weighted decision matrix.
The trash can consists of two chambers, a front chamber for lightweight trash and a back chamber for heavier trash. The top section has two flaps, and which flap the trash is let into is determined by its weight. The front compartment for the lightweight trash has water intake and drainage holes. The trash is initially put into the entry point, where it is weighed, and the trash can then determines which flap to let it go into. The heavy items will slide to the back compartment, and the light items go into the front compartment. However, the issue with this weight sorting system is that it likely cannot tell the difference between paper towels and other lightweight plastic trash. But after recognizing this, we have found a way to sort the paper towels from the other plastics that the system would confuse it with. At the end of the day, the lightweight trash section fills with water and swirls around. This causes the paper towels to absorb the water and sink below the plastic trash that floats. The floating trash can be removed from the top layer of water and placed with the other trash. The water drains, and the paper towels remain in the bottom. This can cause issues with wasting water, so our system uses drainage water from the sinks to separate the paper towels from trash, which minimizes the environmental impact.
Trade-offs we face with our final solution were the cost, since the solution requires a weight sensor, as well as the possibility of the solution malfunctioning or users tampering with the system. Other trade-offs we had to make design-wise were based on the aesthetics of the design. To include all of the weight sorting devices, we had to compromise the sleek design of the apparatus. Size was also a trade-off we had to deal with and was a concern when receiving feedback.
We are measuring success by its ability to sort garbage from paper towels, specifically lightweight wrappers. We will measure how much non-paper towel contaminants our prototype collected out of a fixed number of contaminants placed within the trash. For our testing protocol, we placed paper towel and a fixed number of small wrappers within our prototype and counted how many pieces were successfully sorted. We conducted this test 3 times. To sort the wrappers from the paper towel, we simulated the adding of water to our prototype and observed that paper towels sunk and contaminants floated. Another metric we considered was the fact that this prototype does not require any change in behavior from the user. The prototype does the sorting on its own. The third metric we considered was safety. While we cannot simulate an actual metal design of the prototype, there are no exposed edges or flaps that would catch any limbs.
The criteria and constraints that we had for our prototypes included reliability, ease of maintenance, easily implemented to restrooms, cost, and safety. Prototype number 3 was the prototype we chose based off our weighted decision matrix because it scored the highest. The limitation that prototype number 3 has is that other paper products sync with the paper towels.